Hello, good morning. Today we will present and explain our experiment popularly known as quicksand. In it we use cornstarch and water. We put them in a container and mix them until they form a homogeneous mass. After the mixture is ready, we can notice a very interesting phenomenon. When you put your hand very slowly into the mixture or stir it with a spoon, you will notice that your hand will go immediately, as if were a liquid.
However, when you bang your hand very hard on top of the mixture produced, it is noticeable that it behaves as if it were solid, not letting your hand go through its surface. What you may be asking yourself is, why does this happen? That is what we are about to explain. The explanation lies in the fact that the mixture made is a non-Newtonian fluid. And what does that mean? Newtonian fluids are those that have a constant viscosity. That is, they follow Newton's law and do not change when a force is applied. Good examples are water, or milk, or even gasoline. Non-Newtonian fluids, on the other hand, are those whose viscosity varies with the degree of deformation applied. Therefore, they do not have a well-defined viscosity. In our case of cornstarch, there is a concomitant increase in viscosity with the applied force. Viscosity is the resistance of a fluid to flow. In other words, the higher the viscosity is, the lower the speed at which the fluid moves. The viscosity of any fluid comes from its internal friction. In liquids, the internal friction comes from the forces of attraction between relatively close molecules. Now, answering the question objectively, the mixture is a suspension with a solid, in our case the cornstarch, dispersed in a liquid, the water. The impact strength lies between the cornstarch chains and forms a semi-rigid structure. But when the pressure is released, the cornstarch flows again, which is essentially the same event that occurs with quicksand. This peculiar experiment, which arouses so much curiosity, can be useful or a part of our everyday life. To justify this statement, we have as an example the use of a substance with similar properties that reacts similarly to the liquid produced in our experiment. That is being actively used as a speed breaker in Villanueva de Tapia, Spain, having the purpose of causing impacts like those of a traditional speed breaker for those who are over the speed limit and for those who are not to go unnoticed, and is being considered for use in countries such as Israel and Germany. If the vehicle travels at a low speed, the fluid has a low viscosity and the strip is easily deformed. Whereas if the speed of the vehicle is high, the viscosity of the fluid is high as well, and as a result has great resistance to deformation, thus forming a rigid obstacle to the movement of a vehicle. Drivers must slow down when driving over the conventional speed breaker to prevent damage to their vehicle. However, this non-Newtonian fluid speed breaker is sensitive to the speed of the vehicle, so the vehicle needs to slow down only if it is overspeeding. This concept is more balanced in our point of view, because it is fairer for the reason that drivers driving at the appropriate speeds in their respective environments are not affected. Well, that was our presentation, and we hope you enjoyed it.